operating with scientific notation. The first thing we need to do is a little review of what we learned a couple lessons ago about exponents and their rules. Okay? So keep in mind that for multiplying and dividing, you need to have the same base. And when you're multiplying terms with the same base, you're going to add the exponents to get your answer. When you're dividing terms with the same base, you're going to subtract the exponents and then write down your answer. Keep in mind that with division, it's very important to keep your placement, right? So not to mix up the order in which your terms are in, otherwise you'll get the wrong answer. And then lastly, we have raising a term to another power or another exponent, and you're going to just multiply those two exponents together to get your answer. Okay? We're going to be using these with our scientific notation. With our scientific notation to do some division and multiplication of really large and really small numbers. Okay? So here we have a sample for division with scientific notation, which is our first concept. And this one is probably not too difficult, right? You could probably do this one on a calculator because the exponents aren't that big. We have 8.8 times 10 to the 7th, so if we move this over 7 spaces, that would be 88 million. And this bottom one, if we move the decimal point over 3, that would be 4,400, right? That's something your calculator could handle. But if we had a problem like this, suddenly this is too many places for your calculator, and your calculator cannot do this problem. Okay? So we need to know how to do that ourselves. All right, and what we're going to do is we're going to actually break this problem into two separate pieces. Okay? We're going to make it two different fractions because it's pretty easy to do 8.8 divided by 4.4. Right? That's a pretty easy division problem. And it's pretty easy to do 10 to the 17th over 10 to the 13th with those rules of exponents that we just worked on. Okay? So this is a pretty difficult problem, but each of these individually are not too bad. Okay? So that's our first step, is to break it into two. And then I like to subtract my exponents first. So that would be 10 to the 17th minus 13, or 10 to the 4th. And then over here I have 8.8 divided by 4.4, and I know that's going to be 2. Okay? 8.8 is twice as big as 4.4. So I have subtracted my exponents, I've divided my coefficients, and that's what these numbers are called. These numbers that you are multiplying by 10 to a power, these are called coefficients. And then you want to combine that all together back into something that looks like a scientific notation problem. And then you might have to convert your answer to proper scientific notation. Okay? In this case, I might just put my 2.0. But sometimes it's not that clean. Sometimes it's a little bit trickier to resolve. So if we look at this problem, with this one I actually want to go back and have, instead of step 1, have a step 0, which is writing it in vertical notation. Okay, so write out my 2.4 times 10 to the negative 6th and 8.0 times 10 to the negative 3rd. Okay? Got a little better heat. Now that it's in vertical notation, I can split it up into my two problems. 2.4 divided by 8.0 times 10 to the negative 6th over 10 to the negative 3rd. Okay. Now I want to do my exponents first, so I have 10 to the negative 6 minus a negative 3. I have two negatives, so those are going to become a positive. So I have negative 6 plus 3, which becomes 10 to the negative 3. And then I need to do my division. Let's see. If I can kind of drop this, 8 doesn't go into 2.4, but it'll go into 24. So 8 goes into 24 3 times. So I'm going to need to have my decimal place over, right, because I'm moving my decimal place over. And that would be 0.3. So I'd have 0.3 times 10 to the negative 3rd. Now, is this proper scientific notation? No, it's not, because this is not a number between 1 and 10. Okay? So to make that happen, we need to move our decimal place 1 over to the right. Okay? And this is a little bit of a seesaw, right? Kind of a balancing act. When I need to move this decimal over to the right, I'm making this part of my number larger. If I'm making this part of my number larger, I need to make this part of my number smaller. So if I'm going over 1 to the right here, and making it 3.0 times 10, I need to decrease this by 1, because I moved my decimal place to the right 1. And so these two numbers are the same, but this is proper scientific notation.